Hello everyone, I welcome you all to this lecture on Video System Basics and Working of the Module 12 on Video Equipment Basics of the online course on Domestic Equipment Maintenance. In the previous module, we have gone through the Audio Equipment Basics. In this lecture, we will cover the fundamentals of video system, its working principle and the steps involved in the operation of a video system. So let us begin with the topic, an introduction to video system. A video system is a collection of interconnected hardware and software components that work together to capture, process, store, transmit and display visual data. The main aim of a visual system is to manage and deliver video content efficiently and effectively. The eye is a center of human visual system through which the perception of vision is captured for subsequent extraction of information by the brain. Visual perception is generated when eye captures the visual rays of light reflected from an object. The resulting perception is called eyesight or vision. A video system is used in many fields including entertainment, education, surveillance, communication, advertising, healthcare, gaming and many more. Ongoing technology advancements consistently enhance the quality, accessibility and adaptability of video systems, making them an integral part of human life. Now, let us discuss some topics that are important to know when we are talking about a video system. So first is image basics. The image is a two-dimensional structure which records light intensity variations along x and y axis. The light intensity variations are called gray levels. Image can be defined to be a function fxy where x and y are coordinate values in a 2D plane. This figure shows an image with an image point fxy as a function of the coordinates x and y. The values forming the image are proportional to the intensity of light recorded at a given point. The image thus created when is transferred to a computer becomes digitized and contains discrete ranges of values. Discretization is to convert into samples that is placed in distinct states. The discretization of an image captured by an analog camera involved the sampling theorem proposed by Nyquist. The sampling theorem states that a signal can be completely recovered from its samples if the signal is sampled at a rate equal to or greater than the inverse of twice the maximum frequency component of the signal. Thus, in case of an image captured by an analog camera, if it is to be discretized and stored inside the computer, it must be sampled. The discretization produces a digital image. The image captured by a digital camera or a scanner are all in digital form. Now, pixel and resolution. The conversion process of an image into a form suitable for a computer is dependent on sampling. Sampling means to select picture elements at definite points. An image, when it is converted to a form suitable for a computer, describes the image contents using a description where the number of picture dots forming the image becomes critical. The greater is the number of picture elements, better will be the picture details. The picture information is optical in character and may be thought of as a grouping and may be thought of as a grouping of a large number of bright and dark areas representing picture details. These elementary areas into which picture details may be broken up are known as picture elements or pixel. Pixel is a smallest unit forming a digital image. In color system, each pixel has typically 3 or 4 components such as red, green and blue that are known as a primary color, and cyan, that is a mixture of blue and green color, magenta, that is a mixture of purple and red color, and yellow, which are called secondary color. The total amount of pixels within an image is often referred to as is resolution. The number of distinct colors that can be represented by a pixel depends on the number of bits per pixel. A 1 bit per pixel image uses 1 bit for each pixel, so each pixel can be either on or off. It is called a binary image. Each additional bit doubles the number of colors available. So, a 2 bit per pixel image can have 4 colors and 3 bit per pixel image can have 8 colors. So, this is the chart. High color is represented using 16 bits and the true color is the color represented by using 24 bits. Resolution. The resolution determines the visible details of an image. It represents the density of gray levels or information contained in an image. Higher resolution means more pixels, which usually translate to a sharper and more detailed image. Resolution is an important factor in determining the clarity and quality of digital images, whether on screen or in print. Resolution types. So first type is pixel resolution. This is used in case of images. Pixel resolution is expressed as a set of 2 positive numbers, where the first number is the number of pixel columns and the second is the number of pixel rows. For example, 640 by 480. The next is a spatial resolution. It refers to the number of independent pixel values per unit length. It is a measure of how closely lines can be resolved in an image. It is used in remote sensing and GIS. Spectral resolution. It is associated with color image to distinguish between different wavelengths or frequencies of electromagnetic radiation within a spectrum. Temporal resolution. This is a type of resolution associated with time. Temporal resolution can be used to provide resolution distinction of motion picture. Sequence recorded with different rate in frames per second. Movie cameras and high-speed cameras can resolve events at different points in time. The time resolution used for movies is usually 15 to 30 frames per second, while high-speed cameras may resolve 100 to 1000 frames per second or even more. Many cameras and displays offset the color components relative to each other and mix up temporal with spatial resolution. Let us now discuss about the key components and functions of a typical video system. First, we begin with the hardware components. Number 1, camera. One of the most important hardware component of video system is digital camera, which is used for capturing images. It uses a special semiconductor chip that is called CCD, that means charge coupled device, to convert light to electrical signals right at the image plane. The quality of the image created in this way is closely related to the number of pixels the CCD can capture. There are various types of cameras to produce high quality digital images. Depending on the use, they are studio camera, field camera, prosumer camera, sitting camera, drone camera, infrared camera, DSLR camera, spider camera, etc. In Module 13, we shall discuss in detail about digital camera. The next hardware component is the microphones. Microphones are used to capture sound associated with video. They can be integrated into cameras or used as separate device for better sound quality. Number 3, cables and connectors. Various types of cables like HDMI, VGA, DisplayPort, USB, etc. and connectors are used to transmit video and audio signals between different components of a video system. Video processing unit. The video processing unit is a type of microprocessor that made for video encoding and decoding. This unit processes the raw video data, performs encoding and compression, and also apply effects or enhancements to the video signals. Graphics processing unit, or in short GPU. The GPU is responsible for rendering and displaying the video content on the screen. It helps in processing and enhancing the visual quality of the video. Central processing unit. The central processing unit handles various computation and tasks related to video processing, encoding, decoding, and software applications associated with the video system. The next component is visual display. Monitors such as a television, computer monitor, or mobile device or projectors are used to display the video output. They come in various types and resolutions such as LED, LCD, OLED, that is organic light emitting diode, etc. We shall discuss about these components or about these devices in the third session of this module. The next is memory. The random access memory stores temporary data and instructions required for video processing and playback. Storage devices. Hard drives and solid-state devices are used to store video files, applications, and other data related to the video system. Power supply unit. The power supply unit provides electrical power to all the components of a video system. Next is motherboard. The motherboard serves as a main circuit board that connects and allows communication between various hardware components. And the last component is a network interface. The network interface like Ethernet port, Wi-Fi card are used to connect to the internet for communication. Now let us discuss about the software components. The software components of a video system plays a vital role in processing, editing, storing, transmitting, rendering video content, etc. These components are essential for managing and manipulating video data effectively. The main software components of a video system are: the first is video editing softwares. Software used to edit and manipulate video content, including cutting, splicing, and effects enhancing, adding effects, enhancing audio, and merging clips. Some examples of video editing software are Adobe Premiere Pro. It is a professional software for color grading, audio editing, and more, available for Mac operating system and Windows. Next software for video editing is the Final Cut Pro X. This is a professional software for Mac OS, known for its advanced feature and inbuilt interface. The next video editing software is DaVinci Resolve, a comprehensive video editing software available for Mac OS, Windows and Linux. iMovie. It is a user-friendly software for Mac operating system, iOS devices, and suitable for beginners and casual video editors. Camtasia. This is a video editing software tailored for screen recording, making it suitable for creating tutorials, presentations, and educational videos. The next software for video editing is the Lightworks. It is a professional software available in both free and paid version for Windows, Mac OS, and Linux, and known for its speed and precision. So these video editing software vary in terms of complexity, features and price. They are suitable for various skill levels and specific requirements. Video compressor and encoding software. So the programs that compress and encode video files into format like H.264, H.265, MPG2 and other to reduce file size while maintaining the quality. The media player. It is an application that decodes and play video files in various formats, providing a way to view video content and video contents on computers and other devices. Video streaming softwares. These softwares used for live streaming or delivering pre-recorded video content over the internet to users on different platforms. The next software is a video conversion software. The tools that convert video files from one format to another, facilitating compatibility across different devices and applications. Video analytics software. These applications that analyze video content for specific patterns, behaviors, or information often used in surveillance and security systems. Video production softwares. The tools for creating and producing video content, including storyboarding, special effects, 3D animations, and other creative elements. The next software is video communication software. This software is designed to facilitate real-time video communication, conferencing, and collaboration, enabling remote interaction among the individuals or teams. After completing the introduction part and the various components of video system, let us try these few questions. Well, let us now begin with the topic on working of a video system. So number one is the image capture. Video systems start with the capture of images, which is basically done by camera. The image capturing process involves converting optical information into electronic signals. They capture a continuous stream of images, typically at a specific frame rate, for example 24 frames per second for film or 30 frames per second for televisions, which are then combined to create the illusion of motion. Next is the image processing. captured frame undergo image processing, which involves enhancing the quality, adjusting color, contrast, and sharpness, and removing noise or unwanted elements. The next step is the video compressor. The video data is often compressed to reduce file size and facilitate efficient storage and transmission. Popular video compression standards include H.264, H.265, HEVC, VP9, and AV1. The next steps is the storage. Compressed video data is stored in various storage devices like hard drives for a later retrieval and playback. Then transmission. Video data can be transmitted over various channels including the internet, satellite links, cable networks, or local area networks. During transmission, data is often further compressed to optimize bandwidth uses. Decompression. After reception, the compressed video data is decompressed to its original form for processing or playback. The next step is the video playback. Decompressed video frames are rendered and displayed on a screen to allow viewers to watch the videos. Standardizing the basic and working of a video system is important for anyone involved in a video production, broadcasting, or multimedia technology. The advancement of video technology continue to evolve, leading to higher resolution, better compression techniques, and improved viewing experience. So dear learner, after completing the working of a video system, let us now try to attempt these questions to test our knowledge. Dear learner, thus we have come to the end of the session. Hope you have learned the fundamental video system including its components and working. In the next 2 sessions of this module, we will focus on some devices based on video processing. Thank you.